Cool. So, yeah, welcome everyone. And I think we can start the session now. So welcome to today's webinar series, Citizen Science webinar series. And this is the fourth among a series that we're holding. And this is a partnership between the YESS community and the World Meteorological WWRP program, High Weather Citizen Science Project. And this is a webinar series exploring the role of citizen science in weather, climate, and related projects. We had 3 very great sessions from before today. And if you missed them, just go online and look at them. But so we're very excited to have today Dr. Kulkarni, and he will be talking about the initiatives they have at the Center for Citizen Science in Pune. But before we go there, we'll just give a brief overview of high weather and YESS and a little bit of code of conduct before we go to the talk. So as I said, this is a partnership between high weather and the YESS community. So high weather is a WMO WWRP project. It's a 10-year international research project which we seek to advance the predictions on hazards resulting from urban flooding, disruptive events such as wildfires, and etc. And this particular project, we're looking into citizen science and how that helps our science. How can we engage citizens in improving our science? So if you want to follow us, we have a Twitter page. We also have our website. And we're very, very happy to have partnered with the YESS community in delivering this webinar series. And Faten will introduce the YESS community. Yeah.
So hello everyone, how lovely to see you again for the first edition of YESS WMO High Weather Impact webinar series. Thank you, Marion, for the awesome introduction of the project. And before handing over to Professor Kulkarni from the Citizen Science Center in Pune, I would like to give a brief presentation about YESS community, the Young Earth System Scientists. Young Earth System Scientists, YESS community is a unified international and multidisciplinary early career researcher in a powerful network. We try to provide a voice and leverage for a better future to serve the society. So YESS has been officially endorsed by WWRP and WCRP, the research arm of World Meteorological Organization. And also YESS has a close relationship with COW. YESS is also represented in international initiatives and organizations such as Future Earth. So you might see the structure there. For YESS, within YESS, we have 4 working groups. And every member can join one of the working group and can be active there. For example, this webinar series is organized by the online working group. So our council is also open, so you can just join, and we'll be very happy to interact with you and to give you more information and details how we work there. Also, we have executive community and we have regional representative. So all information will be available on our website. So everyone can join YESS, and you are very welcome to interact with us. And we invite you to check the updates on our website. And if you have any question, inquiries, please try to contact us. Maybe Marion, I can go to the code for conduct, please. Okay, so for this webinar, Siri, you prepared this kind of code of conduct. Maybe you can take a few seconds to read it carefully. But what we also would like to inform you that we are recording all sessions, and then all sessions will be available online. And also we will have to elaborate a report after the webinar series. So this is also one of the announcements we made there. So now I give the floor to Marion to introduce our speaker, and then we will be listening to one of the awesome talks for this webinar series. So thank you, Marion. The floor is yours.
Yeah. And just to add to that, if you have any questions, look for the chat box, put it in the chat box. All right, so I'll stop sharing now and allow Professor Kulkarni to share, and then I'll give an introduction, a quick introduction. Okay. Dr. Kulkarni is the founder and the vice president of CCS, Center for Citizen Science in Pune. He is a retired senior scientist from the Indian Institute of Tropical Meteorology, Pune, India. He was team expert of weather modification research with WMO. and he has more than 125 publications. He's the chairman of India Meteorological Society in the Pune chapter. He was also advisor to cloud seeding programs. And he was also an instructor to pilot pilots for aviation meteorology courses in India. He is very well respected, and he's given guidance to more than 25 students to complete their dissertations as well. So he's very has a lot of achievements and a very impressive bio, and we're very happy to have him here with us today, and hope that we can learn something from you, Professor.
Hello everybody. I express my sincere thanks to organizers of High Weather and YESS community, to Marian Tan and Fateh Bahar for giving me this opportunity to present the work. The title of my talk is Landslide Prediction System developed by Center for Citizen Science, Pune in India. I am Kulkarni presenting the work, but work is done by team of citizen science, and these are the co-authors of the work, Citizen Science India, and this is our address, satarkindia.wordpress.com. So I will give brief about my Center for Citizen Science. It is a voluntary organization established on 23rd March 2012. Objectives to promote citizen science in India and solve various social environmental issues with the help of science and technology, to work as a bridge between society and research institutes, to initiate research projects and science outreach programs where citizens and researchers are working together. The CCS is working under the guidance of retired and working scientists from various national institutes in Pune. These include Indian Institute of Tropical Meteorology, where I was working as a scientist for the last 40 years, then India Meteorological Department, Inter-University Center for Astronomy, Astrophysics, that is IUCA, National Center for Radio Astrophysics, NCRA, National Center for Cell Science, NCCS, National Chemical Laboratory, Agarkar Research Institute, and Indian Institute of Science, Educational and Research. These are the photographs of the team members of the Landslide Prediction Project, Satark. So some of the CCS ongoing projects are Satark Landslide Prediction System, Project Meghdut, Khagol Vishwa, that is Astronomical Studies and Popularization, Citizen Science Network, Lunar Study and Conservation Program, Project Sahyadri, that is documentation of geoclimate and biodiversity of Western Ghats of India, Light Pollution Monitoring, Maharashtra Drought Monitoring Program, Nature 24, Observing Nature and Monitoring Seasonal Changes, Study of fireflies in Western Ghats of India, hailstorm, dust storm, thunderstorm monitoring. Motivation of our work. On 30 July 2014, a major landslide occurred in the village of Malin. Its location is given at 19 degrees north latitude and 70 degrees east longitude in the Ambegaon Taluka of Pune district in Maharashtra state in India. The landslide hit early in morning while residents were in sleep. Total 151 people died. In addition to that, 160 people were believed to be buried under the debris. Heavy rainfall occurred over the area for 3 days before the incident. This is a picture, left-hand picture shows the village before the landslide, and right-hand picture shows the village after the landslide. So everything was buried under the mudslide. And the ground survey team of Satark visited the Malin for study of the event. The motivation, again, the GSI survey after the incidents identified 20 more villages in the mountain range along the west coast of India which is known as the Western Ghat. They are prone to landslides. This raised concerns about the safety of the people residing in such vulnerable areas. Risks and damages due to landslide increase in many areas over the Western Ghats region in the recent times due to increase in population residing hillside, increase in road and building construction activities near the hillside. As a consequence, a demand arose in all sections of society for identifying landslide-prone areas and, if possible, an early warning system, early warning of landslides over the Western Ghats region, or taking proactive measures. Incidents of landslide, they include rock slide, rockfall, debris fall, occur at many places in the Western Ghats region in the Indian summer monsoon season, which is for the period June to September. In the past, information of such incidences remained confined to the local areas and hence was missed the attention of the people at large. West Brom 2009 prepared a global landslide susceptibility map based on the indices derived from 6 parameters: slope, soil type, soil texture, elevation, land cover, and drainage density. The map shows that the Western Ghats region of India has high susceptibility index. This is the figure by Kirschbaum showing the global landslide susceptibility index. It index ranges from 0 to 5. 4 and 5 denote the high susceptibility index, that is color yellow and red. And this is the Indian region, and this inset is the Western Ghats region where the susceptibility index is 5. The maximum is for this region in Himalayan region. So this area is very susceptible for landslides. The factors which drive the landslides are grouped into 2 categories. One is the preparatory variables and the other is dynamic triggering. The preparatory variables are topography, tectonics, geological history, weather, and land use. The dynamic triggering factors are heavy rainfall, earthquake, coastal erosion, and construction activity. The link between the heavy rainfall and landslide has been discussed by many authors. Continuous heavy rainfall increases pore water pressure and decreases soil cohesion in the soil subsurface. This develops sliding force which overcomes resisting force to activate the landslide. Then, based on the rainfall, heavy rainfall, a rainfall intensity duration curve, that is RID, has been developed. And this approach has been used by many scientists in the world. For example, Kane, he has used for landslide prediction system. Weizhou used for RID method for the California. Larson and Simpson used RID threshold for Puerto Rico region. Glade estimated RID threshold for North Island and New Zealand using daily rainfall data. Gabet developed RID approach for Himalayan region of Nepal. Then Kulkarni established RID threshold for Garhwal Himalayas, India, and Guzetti used this method for predicting the landslide in European region. After the launch of Tropical Rainfall Measurement Mission TRMM satellite, rainfall data over the tropical region became available to researchers. TRMM multi-satellite precipitation analysis, that is TMPA rainfall data at 0.25 by 0.25 spatial resolution and 3-hourly temporal resolution has shown promise in predicting landslide events using statistical and empirical methodologies. Hong used TMPA rainfall data over the latitude band 50 degrees north to 50 to calculate average RID based on 74 landslide events and identified during TRMM operational period, that is 1998 to 2006. Then this TRMM data has been used by Kiefer. SBOM developed a global landslide hazard algorithm to forecast areas of potential landslide occurrence in real time by combining landslide susceptibility with TMPA derived rainfall estimate. SBOM created an online decision support system for forecasting potential landslide activity in near real time, termed as landslide hazard assessment for situational awareness. This diagram shows the Western Ghats region of India. The red line shows the Western Ghats mountains, which are running parallel to the west coast of India, and blue line shows the motor road from Mumbai. This is north in Mumbai and south is Bangalore. And these numbers, 3-digit numbers, show the height of tops of the mountain, Western Ghats mountains for this region. They are around 600 to 800 meters above sea level. And these are some of the locations, cities in the western coast of India. This is Aurangabad, Buldana, Mumbai, Nasik, and others. Now, to study the landslide, we have collected landslide data from various sources, which include press reports, media reports, local contacts, and government machinery. SBOM introduced the metric called confidence limit for identifying the location of landslide. All the locations identified in the study area have exact latitude, longitude, indicating high confidence in the locations. The study area is divided into 7 sub-areas. These are the names of the cities: Aurangabad, Buldana, Mumbai, Nasik, Raigad, Ratnagiri, and Sindhudurga. The number of collected sites, there are 131 hotspots of the landslide in these 7 areas. Statistics of these landslide events. The earliest event on our record is on July 2000. So we have the data from July 2000 onwards. Number of landslides increased with time due to increased awareness about the landslide and therefore improved reporting of the events in the media. Earlier landslide might have occurred, but those have missed the reporting. Now, if you see the monthly distribution, June has 15% of the events. These are associated with high rainfall during the onset phase of monsoon. Monsoon starts in the month of June, establishes by the end of June, and July and August are the peak monsoon months, Indian monsoon month. So July and August account for 74% of the events. September is the month of withdrawal of monsoon. September has 9% of event. May and October, these are the May is the pre-monsoon month and October is the post-monsoon month. They account for the very small event, 2% of the event. Multiple landslide events occurred on a single day in July and August. For example, on the 1st August 2016, maximum 10 events occurred. Large-scale synoptic system which prevailed during the landslide event. On 90% of event, a low-pressure system was present over the Bay of Bengal or Arabian Sea. 75% of events, the west coast trough parallel to the west coast of India over the Arabian Sea was present. 50% of the events, cyclonic circulation, that is called Sizer, in the middle troposphere, 850 to 500 HPA level was present over the central India. Thus, LPS is found to be most influential for high rainfall and continuous rainfall activity to cause the landslide occurrence. Hawk 2006 concluded that production of landslides requires intense rainfall sustained for at least brief period of time. So it is not only high rainfall, but it is the rainfall, sustained rainfall, which causes the landslide. The reason is the soil gets wet up to a certain depth depending on the location. Continuous rainfall is effective in increasing the wetness depth of the soil. Synoptic scale systems have a characteristic period of 7 days. The rainfall intensified due to synoptic scale system activity remains active for a period of 1 week. Hence, a cumulative rainfall for 7 days prior to the event, so minus 7 days, and to the event at 0, which we call it the event day at 0, has been considered in the present study as a threshold for landslide occurrence. So different workers have derived the rainfall intensity duration curves. These are some of the curves by different workers: Kane, Hong, Costa, Innis, and Guzzetti, and this is the universal global rainfall intensity duration curve. E is the global rainfall intensity duration curve. We have taken all the 57 landslide events for developing the model, and for each of the hotspots, we develop the rainfall intensity duration curve. This is one example which I am showing, case example for a landslide over the West Coast region. So 1 day rainfall, if it is a 50 millimeter and intensity, maximum intensity is 6 millimeter per hour. If the 3-day rainfall, accumulated rainfall is 100 millimeter with the sustained intensity of 4 millimeter per hour, and 7-day rainfall, accumulated rainfall is 300 millimeter with the sustained intensity of 2 millimeter hour, then that spot or that site is prone for the landslide occurrence. Probability is high for landslide occurrence. India Meteorological Department, IMD, issues short range prediction for 72 hours and medium range prediction for 10 days. These have been used to anticipate the occurrence of high rainfall episode. As a guidance, IMD publishes Indian Daily Weather Report, IDWR, which covers the descriptions of synoptic system present on every day. IDWR data has been used to understand large-scale systems causing high rainfall prior to the landslide events. Also, we consider the probabilities of occurrence of extreme rainfall events. These are obtained from predictions given by 5 international center models. These are ECMWM, that is European Center for Medium Range Forecasting, reading UK, UKMO, United Kingdom Meteorological Office, JMA, Japan Met Agency, NCEP, National Center for Environmental Research, US, and MCGE, Multi-Center Grand Ensemble, US. So these forecasts from extreme rainfall forecasts from this center have been used to take the guidance for the prediction of the landslide. Then we give the prediction in 3 stages. First is the worst stage. If the rainfall forecast of IMD over the landslide prone areas shows intense activity for coming 7 days, then on first day of the forecast, worst stage is invoked. The people in area are sensitized to keep watch on the rainfall intensity and duration. The rainfall at the landslide location is monitored continuously. Rainfall data from the different sites has been used. This is maharain.maharashtra.government.in, that is the Maharashtra Rainfall Rain Gauge Network, then mrsac.maharashtra.gov.in weather. So have been used to monitor the rainfall. Then if the rainfall persists for next 3 days and accumulated rainfall crosses the reference value, then alert stage is invoked. Warning stage, if the rainfall persists for next day, that means per day is the watch stage, then 3 days is the alert, and the 5th day is the warning stage. If the rainfall persists for the next day, that is on the 5th day, and accumulated rainfall crosses the reference value, then landslide prediction is given. Then after doing the prediction in the season, we prepare the report of the landslide. This is one example, report of landslide in Maharashtra for 1st August to 8th August 2016. Then the performance of the model, the system was launched on 15 August 2015. 15 August is an Independence Day of India. So in that month, there were 7 events occurred over the Mumbai, Pune, Raigad, Ratnagiri region, and out of that 6 events were forecasted. In Sindhudurg and Goa, that is southern part of this study area, 3 cases occurred in which forecast was given. In all 3 cases. There was success is 85% in Mumbai, Pune, Ratnagiri North region and 100% in the South region. This is the example of our report. For example, for the 1st August, this is the meteorological condition from Indian Daily Weather Report that gives the location of the description of the synoptic system where the low pressure area is present, cyclonic circulation and west coast trough. All the information is available and we document in our report. Then we use the IR satellite pictures to understand, to locate the deep convection for every 6 hours. This is 0 GMT of 1st August, 6 GMT, 12 GMT, 12:30, 18 GMT, IST, Indian Standard Time. So then we see the wind and surface maps obtained from various sites. This is from null school dot site. This shows this is the Indian region, and these are the winds, strong winds at 850 HPA of a particular day, and a low pressure system formed over the Bay of Bengal, head Bay of Bengal. This is in the 850 HPA, 700 HPA, 500 HPA. So system, low pressure system prevailed up to the 500 HPA. Strong winds were there over the west coast of India. Then we use the TRMM rainfall accumulated at 24 hours. This shows the picture. This is the west coast of India, and accumulated rainfall on that particular day was 40 in the range 40 to 50 millimeters on 1st August 2016. Then we have the rainfall data of that location from 1 week before that, that is from 26 July, 46 millimeters, 27, 18 millimeter, 28, 23 millimeter, 29, 73 millimeter, 29, 30 July, 11 millimeter, and 31st July 60, and 1st August 115 millimeter. And this is a picture of that area where the debris flow occurred. These are the details of type of landslide, place, area, and date also. So landslides were of different type, where rockfall were there, then mud flow, rockfall, debris flow. So different types of landslide occur. So total in 2016 we had about 30 landslides in different areas, and we have exact locations and type of landslides. Most of them were rockfall and debris flow. This is in a summary of our prediction reality chart. So 31st July, the landslide occur. We had given these are different colors, indicate different stages of our prediction. So this color shows the alert warning was given. So the third warning, the second stage warning was given and landslide occurred. And blue shows watch or prediction was given and landslide occurred. So this shows the prediction was given 2 days before and landslide after 2 days. So on this in this area, this is these different areas, Raigad, Ratnagiri and Sindhudurg on 31st July, the forecast was given and the landslide occurred. On the 1st August also, warning was given and the landslide occurred. Third stage warning was given. And 2 places we have given the alert warning, second stage forecast was given and landslide occurred after 4 to 5 days. So similarly, we have given the 6-stage warning, sometimes after first stage warning, landfall occurred for 5 days and last third stage warning, the landslide occurred within 2 days. This is the nutshell total events during that period, 24 events. Warning was given, means last stage warning was given in 11 cases and we had the landslide prediction after 2 days. Alert was given in 10 cases and watch was given in 3 stages. If you take the total statistics of prediction, August 2015, 70 events occurs, 6 events were predicted, success rate was 85%. Then the next year, because we started our prediction system in August, so August 2015, we have only August data. Then June 2016, there were 2 events, both were predicted. July 16, 5 events occurred and 5 were predicted. August, we have 30 events, 20 were predicted. And September 2016, we have 3 events, landslide and 2 were predicted. Similarly, June 17, number of events were 5 and 5 were predicted. July 17, 10 out of 10 were predicted. If you take the entire total from 2015 to 2020, there were 120 landslide events and we have predicted 96 events. We have the accuracy of about 80% of prediction skill. Now coming to this year's 2020 predictions, landslide warning alert level were given. This is the region and locations we have given. And then remarks in the remarks column, what is the occurrence, and the high alert was given to citizens near hill slope, ghat areas, administration, disaster management and police travelers, and alert was given and landslide occurred. Similarly, watch was given. So watch, we gave the watch, there are about 6 days preparation time is there. So watch was given and watch rainfall next 12 hours and say step. That is the message we give to the local people. Then we had given in this 2020, in August 2020, our Satark team plotted a new high-risk landslide site in Bhima Shankar area, that is one hilly area, high rainfall area of the Western Ghats region, and village Bivade, a small village, about 20 houses situated at river bank. We had given the forecast and requested villagers to vacate the houses to reduce the damages. And this is the picture. After a week, there was the houses were collapsed. This is our people in that area. But because of our warning, people have already vacated house and there were no casualties in that area. These are some of the reports which came in the newspaper of our articles. So Satark against landslide. Then these are landslide foretold after close rain watch. So we give our predictions on our website Satark and to the press and media, and from there it goes to the public at large. So in conclusion, landslide prediction have been issued in monsoon season over different regions of Maharashtra from 2015 onwards. From the past data, threshold intensity duration curve is developed for each landslide location. IMD's India Meteorology Department extended range, medium range, short range prediction are used to get the guidance for rainfall forecast for 1 month, 7 days and 3 days. Then TRMM and MAREN rainfall on the real time is used for issuing watch, alert and warning messages. If the real time rainfall is higher than the threshold value of each site and likely to be continued for next 1 week based on the IMD forecast, the prediction of landslide is issued for the locations in the 3 stages. The prediction accuracy overall is 90%. Prediction of LS landslide event has been displayed on our Satark website. The address is satarindia.wordpress.com. For knowledge of people, disaster management services in Maharashtra for further necessary action. This is my biodata. And follows on Twitter, Satark India, Instagram, Satark India, email satarindia247@gmail.com. Our contact number and address is given here. Thank you very much.
Thank you for your presentation, Dr. Kulkarni. That was a really good presentation and very impressive on this project, Satark, on landslide prediction system. And I could definitely see that there's the motivation to create the system to help reduce casualties, reduce the impacts of these hazards. And really great to see this initiative and to see that actually it's really good that the accuracy is quite high. So really good project. Thank you for sharing this project with us. So I do have a bit just a curiosity on my side. So because the motivation is quite clear, we want to alert people before the landslide occurs. I'm so quite curious, how do you deliver these alerts? How do you warn the public of these hazards once you've kind of predicted that there's this landslide? Yeah. How do you deliver the alerts? Yeah.
Yes, I will answer this question. Based on the rainfall forecast, and we expect rainfall forecast to be continued for next 7 days. The first day we give the watch stage. Watch means there is likelihood of landslide. You have to keep watch on and monitor the rainfall. If rainfall continues, what happens sometimes the per day rainfall occurs and then there is nothing. So then the probability is very less. So watch the rainfall continuously. And for that we give the information on our Satark site, which is communicated to media and press and other things. So what stage is there? There is likelihood. Then rainfall continues for another 3 days. Next 3 days, then probability of landslide occurrence is increased. And then our next stage is alert stage. You have to be alert now. So definitely the probability is going to be 60–70%, and you have to keep watch. And still rainfall continues for 1 day. That means now, and we compare this rainfall, accumulated rainfall, for the threshold rainfall of the rainfall intensity duration curve. We have prepared for each hotspot rainfall intensity duration value. If the rainfall, accumulated rainfall, crosses RID curve, then the probability of the third stage is issued. That is the warning. Warning means now probability is more than 80–90%, and landslide is going to occur within 1 or 2 days. So you have to take the proactive measures. So people are following now, and I have shown one example. People have vacated the houses, and the next day the house collapsed.
Thank you for that. Thanks for that answer. Yeah, so we have a few comments from people online, and I think a lot of them are thanking you for your presentation. We have comment from Dr. Mohan Das, and he says that it's amazing presentation. and it's good to see science and social application, and both of them are quite important. And I think from my perspective, it's like we look at science and how they're applied in terms of alerting and so on. So I guess he's asking, how can we bridge science and the social aspect of this project? How can the bridge be made?
Yeah, we are trying to reach to the people through various systems, from website, from the media, press. We give our information to press people. They uh, publish our forecast, and if it is a warning stage, they publish in a 1 or 2 day prior to that one. So that is one mode of communication to the society. And also we have some WhatsApp group in those areas. So we contact the people in those areas and tell that this area is likely to have landslide in next 1 week. So 1 week's time is good for preparation for vacating the houses or taking the shelter in a very safe places like that. So we try to use every mode of communication, that is media, press, then the telephone, mobile, etc., to communicate and warn the people and to the society.
Yeah, that's good to see that you're using different channels. I think Fatin will want to ask the next question.
Yeah, thank you very much, Marion. Thank you very much, Professor Kulkarni, for the impressive talk on landslide prediction. It was a very informative session, so thank you for sharing all this information and all this great work and project with us. So I take the second question. The second question is coming from Esther de Koning. She's asking about, in case of alert, how do people respond? The response of people in case of alert, and what kind of actions could be taken, evacuate or not? Where do people go if they are evacuated or if they evacuate? Yeah.
When the alert is given, alert is the second stage. So the probability of 60 to 70%. People have to monitor the rainfall, don't have to vacate the houses and other things. If it is a warning stage, then the probability is very high, and it in the night time also you have to be alert, because as I told, first example in the Malin village, people were in the sleep night time, and then the mud flow occurred and it washed out everything. 150 people died in that one. So you have to be awake in the night time when the warning stage is given. If alert stage is given, there is a probability, but there is not very high probability. You have to keep watch on the rainfall. If rainfall is continuously increasing for next 2-3 days based on the forecast, then next stage will come, the warning stage will come, and that's when the warning is given. If you are in the loose house or broken house in the night time, you have to be very careful during that period. Okay. So this way people are informed to reduce the casualties and damages.
Thank you very much, Professor, for your response. We can go to the third question, and the third question is coming from Madhu Chandra. The question is, how much in advance is the LS prediction can be made in the future?
This prediction, the 7 days prediction is sufficient, because this is linked with the heavy rainfall and continuous rainfall activity, and that occurs when there is some synoptic system which has a life of 1 week. So 1 week is sufficient to give the sufficient time for preparatory action. Too long prediction cannot be given more than 7 days, but 7 days prediction is sufficient to take the proactive measures.
Thank you very much. 7 days is great. She's responded to you. Thank you very much. And the fourth question is coming from Lisa McLaren. She's asking, she's also thanking you for the great presentation. And her question is, how many citizens have been part of this project? And how do you encourage them to get involved with this work? What was the hardest part of getting citizens involved there?
Our motivation I have given, there was a incident in the West Coast India where in a Malin village when 150 people died, and there was survey, GSI survey that there are many more such areas prone to the landslides, and there was a demand from the society to have the knowledge of the landslide and if possible prediction. Now there is no system of prediction of landslides in India. It is not coming under meteorology or not coming under geology. So it is an interdisciplinary subject. So no such system is available in India. So this has motivated. Then we search on the website, and NASA is giving the landslide prediction on real time. And then we found that we can apply the same methodology to our region, have to give the predictions. And then we started in 2015, and 5 years we have done continuously, and people are taking the cognizance of our prediction. Sometimes they block the roads, also stop the activity based on our forecast, and that has helped to reduce the damage in the society.
Yeah, thank you for that. Yeah, so I see that you have a large team at the beginning of your presentation, a large team that is helping this project. So what is it like? What's the experience like managing or coordinating a very interdisciplinary team, as you have mentioned earlier? So what are the challenges, and any tips for our listeners, our early career scientists, on working on a project that is interdisciplinary and has combining different expertise from different people? Do you have any kind of comments or at least recommendations on how to work in such a diverse team?
No, this Center for Citizen Science, Pune, is a voluntary organization. There is no bar of age, education, and the gender. Everybody who is interested, who wants to do something, they join the Center for Citizen Science, and we have different projects, and we have experts from different fields. We conduct a preliminary training course, and depending on the interest of the people, they choose the subject like meteorology, like biodiversity, astronomy, and many people are there, about 20, 30 members are there in each group, and they do the research voluntarily. So that is the way we are working. We are not having any resources, or we don't charge. And so this one is a totally social work, and people, devoted people, they join, they spare their time, their experience. And we have the experts from different institutions. For example, for meteorology, IIT, IMD, and other institutes are there. So there are the working scientists and retired scientists. They help, they guide, and they give the they provide the help required. That way, we are joined together with many institutes in India. Okay.
Yeah, that is great to hear that there's such an initiative for people to come and do the social work, experts coming together. It's very inspiring to see, different ages, gender, expertise to come together with this Center for Citizen Science and to work on a project such as this. So yeah, so thanks for getting this initiative going and going through this project and showing us the results of such depth into your research and into your science. And I think it's an inspiration to see that people can come together and citizens from different expertise to come together and work on something together. So we have a question from Mohammed Bordbar. So he's also thanking you for your excellent presentation, and that how do you evaluate the trend in the landslide events over last decades? Do you see any close connection with the decadal strengthening of the monsoons and the intensity of and frequency of landslide incidents? Is there a connection between the strength of monsoons and intensity and frequency of landslides?
Yeah. So I have given getting the data of landslide is very difficult because it is not available at one source. We have to collect from different sources. First of all, in the early, so that data is not available for a long period of time. Earlier, landslide might have been occurred, but they were not reported. It occurs in a remote area, may be available in that local area, but is not available. There is no inventory. So we have to search and go for the different sources for getting the landslide. So there is no, as such, sufficient data to calculate the trend analysis. But getting the recent period data, we have seen the landslides are increasing. The reasons I have told that the construction activity is increased, which damages the rock structure when the construction is being made. The bores have been operated and the blown, so rock becomes brittle one. So recent time, the number of landslide, mudslide have increased. And also the other reason is the extreme events are increasing in recent time because of the climate change activity. So that also has caused increase in the landslide, number of landslide over the region. I have given the distribution of landslide in a season. For example, June is the month when the rainfall onset occurs over India. The soil is dry, so the whatever rainfall is there, it can absorb the water. So June percentage of the landslide is very low, about 15%. But July, August, the peak monsoon month, soil is already saturated. It cannot hold more water, and the pressure of the water over the rock increases, and it creates this sliding force against the cohesive force of the mud, and the landslide occurs. So maximum frequency in July, August, and September again the frequency is low. So that way the variability of landslide is there. And recent time the number of landslides have increased. The reasons are reporting has now increased. Second is construction activities increased. And third is the extreme rainfall events have been increased. So combined effect of all these things, the landslides, frequency of landslide is increased in recent period.
Thank you for that answer, very detailed answer, and we want to acknowledge the audience for asking great questions, and thank you to Dr. Kulkarni for answering the questions, and also want to recognize that there are members from the Citizen Science Center for Citizen Science online. So hello and welcome, and thank you for supporting Dr. Kulkarni and great work that everyone's been doing. So thank you for coming online and also for doing such great work. So we're almost out of time, so just right in time. Thank you for your presentation and thank you for the questions. Great discussion from everyone. We want to take this opportunity to advertise that our next webinar session will be on the 26th of November, and we will be hearing from Dr. Henning Rust, and he will talk a little bit more about weather education, how we use citizen science for weather education. And we'll be very excited to host that session, and anyone online who's keen on that topic, come and engage with us and engage in great discussion. And again, thank you, Dr. Kulkarni, for your time. Thank you to our audience. And maybe Faten, if you have anything to add before we say goodbye.
Yeah, thank you very much. Thank you very much, Professor Kulkarni. It was really impressive talk, and I really liked the fruitful discussion and the great interaction that we have during this session. Thank you, Marion. I just posted information about the next webinar, so you'll find the registration link. So please, you can just go there, and if you have any question or anything, you can contact us. And I look forward to see you next time. Thank you very much, and see you in 2 weeks from now. So
Thank you,
thank
Vivian.
you.
Thank you, Patel. Thank you.
Thank you. See you, everyone.